In this video, we will learn how to find the value of any trig function given one trig value and the quadrant. This would be the quadrant of the terminal side of the angle. Alright, so for problem number 2 here, we're supposed to find the remaining 5 trig functions of theta if cosine theta equals -3/7, and we know we're in quadrant 3. So let's draw that sketch. So if we know we are in quadrant 3, people, then we're talking about this situation. Alright, so here's quadrant 3 happening. If you make a triangle out of it to the x-axis, it's going to be like this. Alright, so even though this is a reference angle, as long as we use the signs, you know, like the, for example, cosine is adjacent over hypotenuse. Okay, so the hypotenuse is always positive, so there's my 7. And adjacent is right here. See how it's a -3? As long as we actually use the negative on the 3, and as long as when we get the y value we make sure it's also negative because it's down, then it's okay that we're using the reference angle, even though the true angle wraps all the way around like this. We will actually get the correct values of the angle. Let's do a little Pythagorean theorem to find this vertical leg over here. So if we do that, then what we have is a squared plus b squared equals c squared. So y squared plus -3 squared is equal to 7 squared. So y squared plus 9 is equal to 49. Subtracting 9 from both sides. Alright, so obviously y squared is going to equal 40. And once you take the square root of both sides, where's my equal sign keep going? So square root of 40, this is 4 times 10, so that's going to be 2 radical 10, yeah? Alright, so y is equal to 2 radical 10. I think we're allowed to use our calculator on this part, so if you really needed to, can I slide this over? If you really needed to, you could go square root, you could go square root of 40 and see your 2 radical 10 right there. Anyway, so this is 2 radical 10. Now be careful, do not make the mistake that I just made. I just had to redo a large chunk of this video because I went on and on and on and had left this 2 radical 10 like this. I said we were allowed to use this reference angle as long as we chose the correct signs on the legs of this triangle, but then I went on to not do that. This 2 radical 10 is down 2 radical 10, so this y value is a negative y value. So please, I had said that it needed to be negative and then I didn't do it, so I'm betting that a lot of people will make that mistake. So don't let it be you. So this should be negative. Now that we have that in place, we should be able to find all 6 trig values. So here I go. Sine is opposite over hypotenuse. So that's going to be -2 radical 10 over 7. Cosine is adjacent over hypotenuse. That's -3 over 7. Of course, that's the one they gave us in the first place. Tangent is opposite over adjacent. A negative divided by a negative is a positive. So that's going to be just simply 2 radical 10 over 3 without the negatives. Alright, and then we can do all the reciprocal trig functions. So cosecant is the reciprocal of sine. Alright, so that'll just be 7 over negative 2 radical 10. Some people like to rationalize the denominator. If you're one of those types, then you'll wind up writing this as 7 radical 10 over negative 20. Anyway, the reciprocal of cosine is the secant function, so that will be 7 over negative 3. And the reciprocal of tangent is cotangent, so that's going to be 3 over 2 radical 10. Again, some people don't like to have radicals in the denominator. So if you were to multiply the top and bottom by radical 10, you would get 3 radical 10 over 20. Okay, so that is how you do that. Before I end this lesson, let's look at one more example. Alright, number 2, part B. So this time we're told that the terminal side lies in quadrant 2, and we're given the secant. Okay, so here we are drawing a picture of quadrant 2. And again, we can use this reference angle, even though the real angle goes like this. We can get away with it as long as we use our negatives and positives correctly. So whatever we put here, this is negative because this x value is on the negative x-axis. And whatever we put here will be positive because it's up above the x-axis. As long as we do that, we can use the reference angle. Now, secant is the reciprocal of the cosine function. Okay, so we know that cosine of theta is adjacent over hypotenuse, right? So that means that the secant function is going to be the reciprocal of that. So that means this up here is going to be the hypotenuse, and this down here is going to be adjacent. Okay, so it's like hypotenuse over adjacent. Now, the hypotenuse can't be negative. So this negative in the front, we're going to put it down here. Now, some students get confused about how negative signs work. So let me clue you in real quick. The way negative signs on fractions work, say if I have a over b, right? And then I've got this negative sign. In fact, let me write 3 a over b's. A over b, a over b, a over b. The following 3 things are all equivalent. I could put negative a over b, or I could put a over negative b, or I could put it right in the middle. All 3 of these are equal. So basically, I can take my negative sign and put it wherever I want. But what you can't do is some students want to look at this one and think, oh, if it's in the middle, then that must be, whoops, that must be the same thing as having the negative on both. But that doesn't make sense because a negative divided by a negative would be a positive, and it wouldn't be equivalent at all. So don't think that. That's crazy. But we can put it in the top, bottom, middle, same thing. So when I see it in the middle, I can put it on the bottom if I feel like it, and I feel like it. So the hypotenuse has got to be radical 27. So there it is, being a hypotenuse. The adjacent leg has got to be negative 5. So there's my negative 5 being all adjacent. As long as I use that negative sign, I'm okay. Now, we'll do the Pythagorean theorem to find this vertical piece over here. So, Pythagorean theorem. I'm going to call this y. So y squared plus negative 5 squared should equal radical 27 squared. So that's y squared plus 25 is equal to 27. The radical goes away. We will subtract 25 from both sides. And that gives us that y squared is equal to 2. When you take the square root of both sides, you see that y is equal to the square root of 2. Okay, there you have it. Once you have that, you can find any trig value you want to. But in this case, we don't have to find them all. We are being asked to find the sine function only. So, sine, let me use blue. Sine theta is going to be opposite over hypotenuse. So that's going to be radical 2 over radical 27. Okay, I don't know. It's sort of bothering me having all these radicals. Yeah, I'm not going to mark it wrong or anything, so you can relax about that. But I might agree with the people that like to rationalize the denominators on this one. So radical 2 over radical 27, it looks weird to me for some reason. Maybe because I was raised as a denominator rationalizer. I haven't caught on to all this newfangled non-rationalization business. Anyways, well, you know what? We're allowed to use our calculator. Shabam. I'm going to do it. So we have radical, I say radical 2 over radical 27. Right? That is what it was, right? Etch-a-sketch brain. Radical 2 over radical 27. Shabam. See, doesn't that look nicer to you? Instead of radical 2 over radical 27, we have radical 6 over 9. That's much more lovely. So back to the problem. Or radical 6 over 9, which is my favorite way to write it. Whatever, I'll put a box around this too. So, here endeth the lesson.